A body moving with some initial velocity and having uniform acceleration attains a final velocity v, which is equal to root of 180 minus 7x. Find the acceleration of the body. Okay, so this is again a straightforward application of differentiation. So let's start solving this. So we have been given v is equal to root of 180 minus 7x. Now, if you remember that even in the previous topic, instantaneous velocity, we did do questions which were based on squaring on both sides to obtain a feasible solution. So similarly, we'll square this equation, and what do we get? We get v square is equal to 180 minus 7x. Now what we'll do is we'll differentiate this equation with respect to x. Let me differentiating with respect to x. So what do we get? So d by dx of v square is equal to d by dx of 180 minus 7 into d by dx of x, right? Okay, so this is what we get. Now, what is d by dx of v square? 2v? No, it's not 2v, it is 2v into dv by dx. Derivative of 180 is 0 and derivative of minus x is 1, so this becomes minus 7, right? All right, so what do we have now? So we have 2v into dv by dx is equal to minus 7. Now, one mistake, in my opinion, one big mistake what students do here is they, instead of instead of differentiating with respect to x, they do differentiate with respect to time here, which is actually wrong, because you are now interested in getting the answer as acceleration, because acceleration is being asked in the question. So you will differentiate with respect v with respect to t and then obtain acceleration, which is basically wrong, because what you have is in the RHS is x. So when you differentiate v with respect to t, you also have to differentiate x with respect to t, which will give you the velocity. So basically, when you differentiate this equation with respect to time, you are getting an expression in terms of velocity again. So that method won't fetch you any good here. But even in this case, if you observe, we have some point called as dv by dx. What is dv by dx? Well, this is an interesting part of this question. In the solution, I'll tell you why. See, what is acceleration is equal to? Acceleration is equal to dv by dt, right? So what I'll do is I'll just make a very minor algebraic manipulation here. It goes like this: a is equal to dv by dt. We can be written as a is equal to dv by dx into dx by dt, right? Let me make it even more clear. So see, a is equal to dv by dt. There's no doubt about it, right? Now what I'll do is I'll multiply it with dx in numerator and in the denominator. Now the LHS remains the same. Acceleration is equal to, what is dx by dt? It is velocity. So v into dv by dx can basically be replaced as what? It can be replaced as acceleration. So this expression v into dv by dx here becomes 2 into v into dv by dx is equal to minus 7, and therefore 2 times acceleration is equal to minus 7. Therefore acceleration is equal to minus 7 by 2, which is equal to minus 3.5 meter per second square. Therefore acceleration is equal to minus 3.5